When Pluto was officially reclassified as a dwarf planet in 2006, many dismissed it as a forgotten icy remnant lurking at the far edge of our solar system. Once celebrated as the ninth planet, it suddenly became just a distant, frozen rock, a cold, quiet world thought to hold little scientific value. But recent discoveries are overturning that perception in extraordinary ways. Thanks to high-resolution images and data from the James Webb Space Telescope, Pluto is no longer viewed as a silent, lifeless world. Instead, it has emerged as one of the most mysterious and fascinating bodies in our solar system. The visuals returned by Webb challenge nearly everything we believed about Pluto. Once considered dull and inactive, it now appears to harbor secrets beneath its icy crust, secrets that could reshape how we think about the potential for life beyond Earth. At the center of Pluto's icy mysteries lies its most iconic feature, Sputnik Planitia, the giant heart-shaped glacier that has captivated both scientists and the public. This massive expanse of frozen nitrogen is more than visually striking, it is geologically significant. Its immense mass affects Pluto's rotation and gravitational balance, almost as if the planet is weighted unevenly. Beneath Sputnik Planitia may lie something even more extraordinary, a subsurface liquid ocean. Scientists believe that Pluto could harbor a hidden reservoir of water, kept from freezing solid by heat generated deep within its rocky core. This residual heat likely comes from the slow decay of radioactive elements. Despite being nearly 6 billion kilometers from the Sun, this heat may be enough to maintain liquid water below the surface, turning Pluto from a frozen wasteland into a dynamic, evolving world. This possibility is profound. Liquid water is the cornerstone of life as we know it, and where there is water, life is possible. If Pluto's subsurface ocean exists, it could host microbial life adapted to extreme cold, high pressures, and perpetual darkness. Far from the warmth of the Sun, such organisms would thrive in isolation beneath layers of ice, shielded from radiation and cosmic storms. According to physicist Brian Cox, the existence of life in such extreme conditions would revolutionize biology and redefine our understanding of where life can survive. Supporting this theory are signs of geological activity. NASA's New Horizons mission in 2015 revealed Pluto's surface is far from static, featuring fault lines, ridges, and tectonic fractures. These are not remnants of a frozen past but evidence of an interior still at work, reshaping its icy shell. Even more intriguing is Pluto's relationship with its largest moon, Charon. Unlike typical planet-moon systems, Pluto and Charon orbit a point in space between them, creating gravitational tides that ripple through Pluto's crust and possibly its subsurface ocean. These tidal forces may generate additional internal heat, helping maintain geological, and perhaps biological, activity. The James Webb Space Telescope has also detected unusual heat signatures and chemical markers beneath Pluto's surface. Patterns observed in these readings resemble processes on Earth linked to biological activity, though we cannot yet say definitively what they are. Some scientists speculate that Pluto could host life forms so alien that they challenge our very definition of life, thriving in an environment so foreign that it seems almost uninhabitable. Pluto itself likely formed in the early, chaotic days of the solar system, built up from repeated collisions and impacts that generated tremendous heat. Over billions of years, this residual heat, aided by radioactive decay, may have kept part of its interior liquid, creating a world formed by fire, encased in ice, and still active today. Its thin, dynamic atmosphere adds another layer of complexity. Composed mainly of nitrogen, with traces of methane and carbon monoxide, Pluto's atmosphere creates a reddish haze of organic molecules called tholins. These molecules form when ultraviolet sunlight interacts with atmospheric gases and may be key ingredients in prebiotic chemistry, processes that could lay the groundwork for life. Charon, too, tells a story of past activity. Its surface is marked by deep chasms, grooves, and ridges, with strange red caps at its poles, likely formed by gases escaping from Pluto and freezing on Charon's surface. The gravitational and chemical interactions between Pluto and Charon hint at a complex planetary dance, one that may influence geology, chemistry, and perhaps even biology on both worlds. Pluto stands out among the countless objects in the Kuiper Belt, a distant region filled with icy remnants of the early solar system. Most Kuiper Belt objects are cold, inert, and unchanging. But Pluto defies that norm. Its flowing glaciers, shifting ice, active surface, dynamic atmosphere, and internal heat make it an outlier, a place of activity in a region once thought dead and silent. If Pluto can be active, the possibilities for other icy worlds beyond Neptune are tantalizing. Could hidden oceans and internal processes exist on other Kuiper Belt objects, waiting to be discovered? The James Webb Space Telescope has opened a new chapter in Pluto's story, but it has also left us with more questions than answers. The New Horizons flyby of 2015 offered only a fleeting glimpse. To truly understand Pluto, future missions will need to orbit the planet, probe its ice shell, study its atmosphere in detail, and explore its potential subsurface ocean. One largely unexplored area is the possibility of a magnetic field. Though direct evidence is lacking, indirect data suggests Pluto may have some magnetic activity beneath its surface. A magnetic field could protect its atmosphere and subsurface ocean from cosmic radiation, as Earth's magnetic field shields our planet. This invisible force could also explain unusual heat emissions and geological patterns observed across Pluto's surface. Pluto's location in the outer solar system subjects it to unique forces. Gravitational tugs from other Kuiper Belt objects, occasional close encounters with passing stars, and ancient impacts may stir its interior, keeping it active despite its small size. Far from being a static relic, Pluto appears to be a world of riddles, constantly reshaped by internal and external forces. Once dismissed as a cold, dead rock, Pluto now emerges as a planet of surprises. Its glaciers move, ice shifts, chemistry evolves, and a hidden ocean may still flow beneath its surface. It challenges our definitions of what makes a planet active, what constitutes a world capable of hosting life, and how far life might extend in the cold reaches of space. The questions now are as thrilling as the discoveries themselves. What secrets lie frozen beneath Pluto's icy crust? What forces keep it alive in the dark reaches of the Kuiper Belt? And what might be waiting in the twilight of this distant region of the solar system, beyond worlds we have only just begun to explore? Pluto is no longer just a relic from the solar system's past. It is a beacon for the future, a reminder of how little we know and how much there is left to discover. As our technology advances and our reach into space grows, we move ever closer to uncovering the hidden stories of worlds like Pluto. So what do you think lies beneath its icy skin? Keep wondering, keep exploring, and keep your eyes on the stars.